Hey, calculus students. Well, so today I'd like to do all of these integrals. No, really, all of them. So let's get a move on. Um, Many of them are going to be similar. Some are the same. Some are not the same. Um, yeah, that's all I'm going to say about that for right now. But really, if you're comfortable with all of these, you're well on your way to getting a 5 on the AP exam. And if you're not comfortable with these, I might recommend you do some more practice. No, really. It's how you learn the multiplication tables. It's how you learned how to walk. You really need to do some more practice. Okay, here, let's go. 1 over x plus 1 dx. I hope you ended up with ln of x plus 1 plus c. You could do it with a u substitution, where u was x plus 1 if you needed to. How about this integral? 1 over x plus 1 squared dx. 5, 4, 3, 2, 1. Well, you know, that's the same as x plus 1 to the minus 2. And the antiderivative of that is going to be x plus 1 to the negative 1 with a negative out front. Why? Because when I take the derivative of this and bring that negative 1 down, negative times negative is this positive, and I subtract 1, and I've got that. So don't forget the plus c. All right, 1, 2, 3. How about the integral of 1 over x squared plus 1 dx? 5, 4, 3, 2, 1. And you should have tangent inverse of x plus c. Number 4. Okay, what if I have the integral of x over x squared plus 1 dx? Five, 4, 3, 2, 1. Well, I see that this is going to be a u sub, where I have 1 over u to u over 2. And so for me, this will end up being 1/2 ln of x squared plus 1. Don't forget the plus c. Here's my antiderivative there. Yes, you could bring that up and turn it into a square root if you wanted to, but I'm not going to. All right, how about this one? The integral of x plus 2 over x squared plus 2x plus 3 dx. What an interesting problem. Because I'm not actually sure how to do this. This isn't going to factor. This would be x plus 1, x plus 3. No, that would be plus 4. And because I can't factor it, it's not partial fraction decomposition. But if I were to say, hey, what about the bottom being my u, then my du would be 2x plus 2, and I have an x plus 2 there. And it definitely doesn't help me to try and split this into 2 fractions. Huh. That's very interesting. I wonder if this is one of those completing the square ones. I don't think so. But let's see. X squared plus 2x equals negative 3. And I want half of this squared, so I'm adding 1 squared to both sides, and that's adding 1. Okay, so we have x plus 1 squared equals negative 3. And we can bring that x plus 1 squared plus 3. So this is that. No, wait. No. How did you make it onto my list of problems? Are you a typo? I don't know. if you figure out how to do that one, let me know. I'll get you a cookie. Okay. I kind of want to just put that 2. Or I'm going to change that to a 4. But no, didn't have that. So I'm going to move on. I'm definitely going to think about that for a little while longer. Put a star next to it. Okay. The integral of 5 over x squared plus 2x plus 3 dx. Well, isn't that interesting? There it is again. I think that I had envisioned this as a minus. Yeah, let's go back and do that. This is going to be a minus here and a minus here. Because then I can factor the denominator, and the denominator will be x plus 3, x minus 1, over x plus 2. And so now I can see that I can set this up as a over x plus 3 plus b over x minus 1. So with partial fraction decomposition, I get this plus this. I've got two magic numbers. X equals 1, 1 plus 2 is 3, 1 minus 1 is 0, that goes away, 1 plus 3 is 4b. So b equals 3/4. And if I make x equal to negative 3, minus 3 plus 3 is 0, that goes away. Minus 3 minus 1 is negative 4a. Minus 3 plus 2 is negative 1. So a equals 1/4. So now I'm ready to say, okay, this thing that I was very upset about can be rewritten as the integral of 1/4 over x plus 3 plus 3/4 over x minus 1 dx. So let's take a look here. That's going to be 1/4 ln x plus 3. And here, that's going to be 3/4 ln x minus 1. Don't forget the plus c. Yeah, that's much better. I would definitely like a minus there and not a plus. So I was just looking at this one, 5 over x squared plus 2x minus 3 dx, thinking, well, isn't that the same kind of setup? That's going to be a over x plus 3 plus b over x minus 1, because when I FOIL that, I get that. So 5 equals a x minus 1 plus b x plus 3. If I make x equal to 1, I get 4b equals 5. If I make x equal to negative 3, I get negative 4a equals 5. And so now I can have negative 4 and negative 5/4, and here positive 5/4. So I'm ready to integrate. It's going to be negative 5/4 ln x plus 3 plus 5/4 ln x minus 1 plus c. So I got these things. And, you know, I can actually understand this as, oh, look, 2 logs joined with subtraction. So I can rewrite that as this over this, all raised to the 5/4. That's my multiple choice answer. This is fine for free response. All right, let's get back to this happy place. Integral of tangent x dx. Yeah, that should be happier. Well, what do you mean you're not happy? How about if I write it as sine x over cosine x? Does that suggest anything? Right, so your u is cosine x, and your du would be negative sine x dx. Since I only have a sine x dx here, let's make that negative du. So this can be rewritten as 1 over u negative du, or negative 1 over u du, which is negative ln of u plus c. Okie doke. All right, how about this one? The integral of tangent squared x dx. Not just tangent, but tangent squared. No, not a u sub. This is that Pythagorean one. Tangent squared is equal to secant squared minus 1. So I can break that up into secant squared minus the integral of 1. Whose derivative is that? That's tangent's derivative. Whose derivative is that? That's the derivative of x. Don't forget your plus c. So this one was a u sub. This one was Pythagorean identity substitution, and then a pretty straightforward integral. Okay, let's continue on this tangent-y theme. What do I do if I see something like tangent inverse of x dx? Well, I know the derivative of that, but I don't know the antiderivative. I see a function and someone else's derivative. I'm going to do by parts. Tangent inverse x, I get 1 over x squared plus 1 dx. 1 dx, I go backwards, I get x. So what was our parts method? This times this. X tangent inverse of x minus the integral x over x squared plus 1 dx. Now what about this part? How do you do the antiderivative here? Yes, u sub, where our u is x squared plus 1, because our du would be 2x dx. Well, I see an x dx here, so I'm just going to divide by 2. And that means I can replace here integral of 1 over u, du over 2, and we already took care of that part from here. So that's going to be x tangent inverse of x minus 1/2 ln of x squared plus 1 plus c. That is my integral of inverse tangent. So if I take the derivative of this, I end up with that. All right, what's next? Well, how about this one? Integral of secant squared x dx. I know that was really easy. 5, 4, 3, 2, 1. Tangent x plus c. What's the derivative of tangent? Oh, secant squared. This was one of those ones I'm supposed to recognize. What do I do about this one? Integral of ln of x dx? No, it's not equal to 1 over x plus c. That's bad. Instead, use by parts. ln of x, 1 over x dx. 1 dx, x. So when I use our by parts recipe, I get x ln of x minus the integral x times 1 over x dx. Well, that's the integral of 1. So we've got x ln of x minus x plus c as the antiderivative of ln of x. All right, how about this one? Integral sine inverse x dx. Okay, give it a try. You've seen a couple like this. Hey, welcome back. I hope you recognize this as a by parts problem. Its derivative is 1 over square root 1 minus x squared. Here we have 1 dx, and so here we have x. Going backwards. So my antiderivative, x inverse sine x minus integral x over square root of 1 minus x squared dx. Now, as far as this is definitely a u sub. Look, I see the derivative of this function partially here. So if u equals 1 minus x squared, du equals negative 2x dx, I have an x dx, so du over negative 2 is x dx, which means this can become 1 over square root of u times oops, that's in the bottom, du over negative 2. Well, I want to take this out, and I want to turn that into a rational exponent. So 2, and then here, this is u to the 1 half. Okay, so, wait, 1 half? No, it was on the bottom, minus 1 half. So the antiderivative of u to the minus 1 half is u to the 1 half with a 2 in front. Oh, times this negative 1 half. Look at that. So I get negative square root of u, square root of u. So this is then going to be x sine inverse x minus square root of 1 minus x squared plus c. There we go. I know. There's a lot going on here, huh? How about this one? The integral of x tangent inverse of x dx. Well, I see a function and someone else's derivative. That tells me to use by parts. And that's 1 over x squared plus 1 dx. Here I have an x, and I go backwards with x squared over 2. So, what's this going to be? Well, this is going to turn out to be x squared over 2 tangent inverse of x minus the integral of x squared over x squared plus 1 dx. And see this, I'm going to bring it out here, right? Because that's x squared over 2, so that's a 1 half. All right, great, this is done. What about this? Look, the degrees are the same. What am I supposed to do? Long division, x squared plus 1 into x squared plus 0, x plus 0, and I multiply by 1. 1. And I subtract. And I get minus 1. So 1 plus negative 1 over x squared plus 1. So this thing that I couldn't integrate becomes these two things that I can. So we're going to have x squared over 2 tangent inverse x minus 1 half integral 1 plus negative 1 over x squared plus 1 dx. Well, the antiderivative of that is x. The antiderivative of that is inverse cotangent of x, or negative inverse tangent of x. Don't forget this minus goes to both of those. So x squared over 2 tangent inverse x minus 1 half x minus a minus is plus tangent inverse x plus c. Yeah, okay. Wow, this next one comes with a note, secant x dx, and the note says evil. And so I think I'll do this one for you. Yeah, I know how to take the derivative of that, but I'm looking for the antiderivative. And it turns out, and no, you will not see this on the AP exam, if you go to the U of A or ASU and you take honors calc there, you'll see this. So here's what we need to do. We need to multiply top and bottom by a most curious form of 1. I think this is going to work. And I distribute. So I'm getting the integral of secant squared x plus secant x tangent x all over secant x plus tangent x dx. Yeah. So let's make this our u. Now, what's du going to be? Well, the derivative of that is secant x tan x, plus the derivative of that, secant squared x. Son of a gun. Dx. That whole top turns out to be just du. And the bottom is u. So this is the integral of 1 over u du, which is ln of u. So I'm going to have ln secant x plus tangent x plus c. Evil. Who thinks about that? Yeah, but that's the magic. Okay. How about this one? The integral of x to the third e to the 2x dx. Please take care of that one. Okay, did you go with tabular? I did. X to the third, 3x squared, 6x, 6, 0. Here, e to the 2x, e to the 2x over 2, e to the 2x over 4, e to the 2x over 8, e to the 2x over 16. Remember, it's not adding 2 each time, it's multiplying by 2 each time. We go on the diagonal, and don't forget to multiply this product by a positive, this product by a negative, this product by a positive, and this product by a negative. And so you should end up with x to the third over 2, e to the 2x, minus 3x squared over 4, e to the 2x, plus 6 over 8 is 3 over 4, 3/4 x e to the 2x, minus 6 over 16 is going to be 3/8 e to the 2x. Don't forget the plus c. All right. Yeah, tabular. It'll be big one day. I would so much prefer to do tabular here than by parts, because I'd have to do by parts 4 times, and I don't want to do by parts 4 times. How about you do one more? And we'll have x to the third cosine 4x dx. Yeah, give it a try. Hey there. Did you decide on tabular also? I hope so. Tabular is so much easier here. So, this is cosine 4x, but be careful going backwards. What's the antiderivative of cosine? It's sine 4x, and don't forget over 4. What's the antiderivative of sine? Negative cosine 4x over 16. What's the antiderivative of negative cosine? It's going to be negative sine 4x over 64. And if I'm right, I need one more. The antiderivative of negative sine is going to be positive cosine 4x divided by 256. So, plus, minus, plus, minus. So here I'm going to have x to the third over 4 sine 4x. And then here, a negative times a negative is a positive 3x over 16, 3x squared. 3x squared over 16 cosine 4x. And then here I have a positive times a negative minus, I could take a 2 out of here and a 2 out of here, and that's going to give me 3x over 32 sine 4x. And then down here, 2, I'm going to have 3 over 128 cosine 4x with a minus in front, and don't forget the plus c. Yeah, that's a lot of thinking, even with tabular. imagine what that would be like if we used partial fraction. I'm sorry, if we if instead we had done by parts 4 times. Ooh, I shudder to think. Okay, so let's just, yeah, those I'm not worried about, but these. Okay, this one, x squared cosine x to the third dx. What do you think? Yes, I recommend that u is x to the third, du is 3x squared dx, so du over 3 is x squared dx. There's x squared dx, so this can be rewritten as cosine of u du over 3, or 1/3 the integral of cosine u du. Antiderivative of cosine, well, that's just going to be sine of u. Don't forget the plus c, and don't forget to do that back substitution. Sine of x to the third plus c. Nice. So, not everything that instantly looks like tabular is tabular. I'm looking for a function inside or inaccessible and part of its derivative. So, how about this one though? X squared cosine 4x dx. Now that's not a u substitution. Derivative here would be 4. It's not going to get me that. So I see a function, and someone else's derivative. This is by parts. Put the x squared here, 2x dx. Here we have the cosine of 4x dx, and then over here we'll have sine 4x over 4. So this times this, that's going to be x squared over 4 sine 4x minus the integral of this times that. So that's going to be 2x times sine 4x over 4. We can do some canceling. dx. But look, I still have x squared over 4 sine 4x minus, I'm going to pull this 2 out, integral x sine 4x dx. I need another by parts. And it doesn't surprise me, because that's x to the squared. X to the squared brings it to x to the first, and then we'll go one more time. So I'm putting x, and dx, I'm putting sine 4x, and so negative cosine 4x over 4. Remember, all of this is behind that minus 1/2. So we've got x squared over 4 sine 4x minus 1/2, and then this times this, minus x over 4 cosine 4x minus the integral of negative cosine 4x over 4 dx. Woof! Look at all those negatives. Let's do some distributing. So that's going to bring me up to x squared over 4 sine 4x plus x over 8 cosine 4x minus times minus times minus is minus the integral. Ooh, and I'll pull out that 4 cosine 4x dx. All right, well, I know how to do that antiderivative with a u sub. So I'm going to have x squared over 4 sine 4x plus x over 8 cosine 4x minus 1 over 16 sine 4x plus c. Yes, there's a 4 there, and when I go backwards with this to a u sub, u equals 4x, you'll find that extra 4. 4 times divided by 4 again gets me that. All right. Ooh, and there are a couple more good ones here. How about this one? The integral of 4 over x squared plus 9. dx. Do you remember? Give it a try. Hey, so were you thinking inverse cotangent? I'm sorry, inverse tangent. 1 over x squared plus 9 dx. Gosh, if I could make that a 1. And so I'm going to have 4/9 integral of 1 over x squared over 9 plus 1 dx. So my u is the square root of this. U is x over 3. du equals 1/3 dx, or dx equals 3 du. I also know that this is just u squared. So I'm going to have 4/9 integral 1 over u squared plus 1 3 du. Now, of course, I want to take that out, and then that 3 cancels with a 3 there, and I have 4/3 tangent inverse of u plus c, which is 4/3 tangent inverse of x over 3 plus c. No, really, I expect you to do this stuff. Yeah, just breathe and do a lot more of these. Okay, how about this one? Integral of 2 to the x dx. No, really. I know what the derivative is. Do you remember the derivative? Do you remember the antiderivative? You should have 2 to the x over ln of 2 plus c. Yeah, because look, if I take the derivative of this, I'm going to have the derivative of 2 to the x, which is 2 to the x times the ln of the base. And then those cancel, and there it is. Okey-doke. All right, how about this one? The integral of cotangent x dx. Pause the video, give it a try, come back when you're done. Hey, welcome back. I broke this up, like when we did tangent, into cosine over sine. So my u is sine x, and my du is cosine x dx. Huh, look at that. So this becomes the integral of 1 over u du. So I've got ln of sine x plus c. But what if I make just a minor change to this problem and turn it into cotangent squared? What's my integral going to be here? Well, yeah, this is my Pythagorean identity. Remember 1 plus cotangent squared equals cosecant squared? Yeah, it's one of our trig identities that you're supposed to remember. So cotangent squared is cosecant squared minus 1. So substitute. And so now I have cosecant squared x minus, x minus the integral of 1 dx. Whose derivative is this? It's negative cotangent's derivative minus x plus c. There you go. Okay. One more. Okay. Let's do a definite integral. Tangent x secant squared x dx. And what do I see? I see a function and its derivative. So that means I'm doing a u sub. U is tangent x, du is secant squared x dx. So all of this is du. This is u. So I have the integral of u du. Well, that's great. I mean, that's so nice. If you put 0 and pi here, I'm going to slap your wrist. Either you put u bounds here, or you put no bounds. Don't put these x bounds on. Remember how you find the u bounds? You plug in these x values for tangent. Hey, isn't this interesting? The tangent of 0 is 0. What's the tangent of pi? 0. And the integral from 0 to 0 is, go ahead, you know it. All right. So I think that's going to be our review for today. I really don't even need to do the antiderivative here because I'm going from 0 to 0. If I integrate from a to a, that value is 0 because there's no width there going from a point to itself. Okay. Well, I hope this was helpful. I look forward to seeing you in our next video, which for me is going to be the review stations for the unit. Take care, everyone.